You are once again welcome to this class. This is our second class and a continuation of Unit 5, Force, Energy and Power. In our first lesson, we defined what work is. And we say that work is a product of force and speed. We also say that work is done when a force acts on an object and displaces it in the direction of the force. That's when work is done. Let's look at the calculations. Don't forget we said work is calculated in joules or Newton meters. In our example 1, they are telling us that a force of 50 newtons was used to push a box along a frictionless horizontal surface through a displacement of 3 meters. What was the work done on the box? Remember, work equals to force times speed. So, what is the force in this case? The force is the 50 newtons. And these 50 newtons acted on a box, pushing it on horizontal surface, moving it forward, meaning the box was moving in the direction of the force. You see that? So we shall get the 50 newtons, we multiply it by 3. When I multiply N by M, I'll get Nm, Newton meters. When I multiply 50 by 3, I'll get 150 Newton meters or joules. Let's look at another. In our example 2 is a student used 50 newtons to carry a box of books. A student used 80 newtons to carry a box 50 meters away from the parking yard to the office. Calculate the work done by the boy. I'll repeat. A student used 80 newtons to carry a box of books 50 meters away from the parking yard to the office. Calculate the work done by the boy. Work equals to speed multiplied by force. Alright. Now, in this case, we have the 50 meters. But when this boy was carrying the box, he lifted the box perpendicular to him. So meaning that the force was acted on perpendicularly. So in this case, the speed becomes 0. So we shall have the 80 newtons multiplied by 0. And when a number multiplied by 0, the product is 0. So in this case, our answer becomes 0 newtons, meaning no work was done. No work was done to carry the box because it moved perpendicular to the force that acted on it. The box, which was being acted on, moved perpendicular with the boy. He carried it himself. Therefore, no work was done. Thank you. Next, we shall be looking at power. What is power and how do we calculate for power? But we shall be having more questions on calculating work for more practice, and you will have a worksheet about this. So this is just an image to show you what happened to the other boy in our previous slide. This boy is lifting the box. This is a box where books are, and is carrying it from the ground up, maybe to his head, maybe he's going to carry it along his chest. So the force is the boy himself. And how many newtons? 80. The box is containing 80 newtons. So it's not the force is just perpendicular. The newtons is just the weight is perpendicular to the boy. Therefore, in this case, no work is done. I repeat, no work was done because the box moved perpendicular to the force that acted on it. Let's continue with our next slide, and that's about power. Okay, let's look at the second part of our Unit 5, power, work, and energy. We are done with work. Let's look at power. Power is defined as the ability to do work. The energy you put in to do something is what we are referring to as the power. That strength is what we refer to as the power. Remember we said that the standard unit for work is the watts, and the standard unit for time is seconds. Now, what's the formula for finding power? Power is equal to work divided by time, which work is in joules and time in seconds. So in other words, it means that work will always be equivalent to force multiplied by the displacement over time, or work equals to force multiplied by velocity. We shall see what velocity is as we go along. Let's see. The body, the power of the body is either strong or fast, big force or sometimes small at times. You put in big force, you put in a lot of force to do some work. And sometimes you put in very small to do work. We can as well say that power is also defined as the rate at which work is done. We can as well say that power is the rate at which work is done. The amount of work done per unit time. Power is measured in watts. This was named after the British investor, and the name of this British investor was James Watt, that developed the steam engine. So one of the developments of this British investor James Watt is that he developed the steam engine. That's one of his investments that he made, inventions that he made. Power is mostly given in kilowatts, kW, kilowatts, and sometimes in megawatts. You must have learned about these conversions with the teacher Marius in mathematics, changing, let's say, maybe from kilometers to meters and so on. So we have the kilowatts, megawatts, watts, and so on. 1 kilowatt is equivalent to 1,000 watts, meaning that 1 milliwatt is equivalent to 1 million watts. We shall see the calculations when it comes. Okay, let's look at how do we calculate for power. Example 1. An engine did 300 joules of work in 60 seconds. What was the power delivered by the engine? An engine did 300 joules of work in 60 seconds. What was the power delivered by the engine? Remember, power equals work over time, which work is in joules and time in seconds. So this means that the work which was done was 300 joules and it was done in only 60 seconds. So we are getting 300 joules divided by 60 seconds. And when we divide the two, we remain with 50 joule seconds, or call them 50 watts. See you in the next class. Take care. Bye bye.